Alright, today we are officially, jumping into Chapter 7. Section 7.1 is Apply the Pythagorean Theorem. I, again, would expect that today would go pretty smoothly, maybe pretty quickly. I think many of you are already familiar with the Pythagorean Theorem. What's the formula associated with it?
A squared plus B squared equals C squared.
Good job, Rodney. That would be it. A squared plus B squared equals C squared. So our objective will be to find missing side lengths in right triangles. For our warm-ups, we first need to solve x squared equals 100. To get x alone, we would square root both sides. X would equal 10. Now, when you solve problems with square roots next year in Algebra 2, you would have to put the plus or minus. Since we are talking about triangles and generally distances, we don't include the negative. We don't think about distance as being negative. Number 2, what's my first step to solve? Subtract 9. That would give me x squared equals, and then I would square root x equals 4. Number 3 should be pretty easy after yesterday. What is the simplified version of square root of 20? Very good. 2 square root 5. Again, you could break it into square root of 4 times square root of 5. Or you could make your factor tree. All right, on number 4, we are asked to find x. Anybody have any thoughts? Matea?
X over 12 minus x equals 10 over 10.
X over 12 minus x. So we're comparing this little piece to that little piece, and then we're comparing one leg to the other leg. That would work. That's not the only possibility, but it'll work. I'm actually going to erase the picture so I've got some space to work that out. When we cross multiply, what would we end up with? 120 minus 10x. So we'd have to remember to distribute this 10 to the 12 and the minus x. Add 10x to both sides. We have 20x equals 120, which means x would equal 6. That's a review from last chapter with our similar triangles. Questions, concerns? Need more time?
Can you go back to the last slide?
This is the first slide. You mean the answers from the homework?
No, like,
You need the picture back?
yeah.
Okay. Uh-huh. Anything else? Okay. The Pythagorean theorem states that in a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the legs. Okay, so one way to do this would be to say leg squared plus leg squared is equal to the hypotenuse squared. But usually we label these with little letters. Most frequently, the legs are labeled as A and B. The hypotenuse is always labeled with a C, which is what gives us A squared plus B squared equals C squared. It is important to note that the hypotenuse is always what we consider to be C. It is always the longest side. It is always the side across from the right angle. Questions, concerns, need more time? Okay, on we go. Some of you have probably already moved on to this one. Again, whenever you have a right triangle, it could be helpful to label the hypotenuse as C. Which leg you label A and which one is B doesn't really matter. So I'll label the 5 with A, the 12 with B. So then we are just plugging those numbers into the formula associated with the Pythagorean theorem. 5 squared plus 12 squared equals, well, we'll put in an x for C, x squared. 5 squared is 12 squared. Add them together. To get x alone, we need to x equals, beautiful. Taylor.
Would you be okay if I just, instead of writing out 5 squared plus 12 squared, if I just put 25 plus 144?
As long as you're plugging stuff into the right spot, yes. I'd be okay if you started with this step. There should be some work shown, though. Okay, but yes, I'm fine if you start with that step. But you better make sure you're plugging stuff into the right spot. Any other questions? Hearing lots of flipping, so I assume we're ready to keep going? Okay. All right, this time, again, the one that really matters is the hypotenuse. Which one is the hypotenuse here? 8 minus x is the hypotenuse. The other two, really, you could switch them if you wanted to, A and B. So we have 3 squared plus x plus 1. The whole thing gets squared. So I put it in parentheses. Equals 8 minus x squared. Now on one like this, you should probably be showing me this step. If we have to square a binomial, I'd like to see where you were before you did that. So 3 squared's easy. That one's 9. What do we get if we square x plus 1? X squared plus what? Your algebra teachers would be crying right now. What goes in between the x squared and the plus 1? Plus a 2x. Okay, if you're not sure where that came from, remember that we have to double distribute. So we distribute the x, and then we distribute the 1. We combine the like terms in the middle. That's how we got x squared plus 2x plus 1. Questions about the double distribute reminder? Okay, equals. Now on the other side, don't make the same mistake. We've got to double distribute. 64 minus 16x plus x squared. Make sure you're watching out for your signs. In the back, we'd have a negative x times a negative x. That's how we end up with a plus x squared. Does anybody need to see the double distribute that gave us that? Okay. From here, we can clean things up a little bit. On the left side, what terms can combine? The 9 and 1. So we have x squared plus 2x plus 10. Personally, I prefer for my expressions to be in standard form, meaning the highest variable comes first. This is not a requirement, more of a personal preference. So I didn't change anything about the right side, I just rearranged it. What's going to cancel out from both sides? The x squared. If we go to subtract x squared from both sides, they're gone. So now we need to get all of our x's on one side, constants on the other. So what do you want to do? Okay, add 16x is a good idea. Yes. I put it back here.
Oh, okay.
I just rearranged it. So it was positive, so I put plus 64 back there. All right, we add 16x to both sides. 18x plus 10 equals 64. And then we would subtract 10. 18x equals 54, so x equals 3. Are we done? No, they didn't want to know x. They wanted to know the lengths of the missing sides. So what is the length of the hypotenuse? 5. So I'll just put c equals 5. Or you could put 8 minus x equals 5. Are we all alright with the 5? 8 minus 3. What about my other leg? It would equal 4. Okay, there are my answers. John?
Isn't it still squared though?
Is what still squared?
Like C? No, we didn't square root.
So we never had to square root anything because the x squareds canceled out. We did square c when we squared that binomial. Does that make sense? Okay. Good question. You could, of course, always go back and double check yourself. You could make sure that 3 squared plus 4 squared is equal to 5 squared. And indeed it is. Other questions? Who's ready to draw a picture? A ladder, 16-foot ladder, rests against the side of a house, and the base of the ladder is 4 feet away. So in my personal opinion, it's nice to have a little picture. It doesn't actually have to be artistically drawn. Here's my side of my house. There's my ladder against it. And then we could have the ground going across the bottom. Okay. If you really wanted to make the picture pretty, you can. It does not affect the mathematics. So the ladder itself is 16 feet long. So we could label the ladder as 16 feet. The base of it is 4 feet away from the house. So down here, the base of my ladder is 4 feet away from the house. Approximately how high above the ground is the top of the ladder? So this distance over here is what we're trying to find. Do we have questions about the setup of this picture at least? Okay, now we are going under the assumption that you had a contractor who was licensed build your house. So we would assume that this angle down here that the house makes with the ground is a 90-degree angle. Okay, remember the Pythagorean theorem only applies to right triangles. So in this case, are we looking for A, B, or C? A, okay. You could have said B and still been correct. If you had said C, you would have been incorrect. C has to be the hypotenuse. A and B, you can flip-flop if you want. So I'll just leave it as A. If you wanted to give it a different variable, you could. Questions about the setup? All right, 4 squared 16 squared. $256. To get A alone, I should subtract A squared equals 240. And then we would need to square root both sides. Now, on this particular problem, the question said approximately. So if the question says approximately, I'm okay with a rounded answer. So in this case, if we take the square root of 240 and get a decimal, what do we get? What do we get? A little louder for the deaf person in the back. 15.5? Okay. Is that already rounded, or that came out that nice? You rounded it? Okay. We should put units on it. The units would be feet. So it's approximately 15.5 feet above the ground. Questions about example 3? All right, on we go. Find the area of the isosceles triangle with side lengths 10 meters, 13 meters, and 13 meters. Now, this is not a right triangle. This is just an isosceles triangle. So you could draw a generic triangle. I would not try to make any of it look like it's a right triangle. And again, it doesn't really matter what it looks like, it matters how you label it. So I want the one at the bottom to be the 10 feet, and the sides, bless you, on the left, oh, not feet, meters. Meters. To be my 13 meters. Now, if you oriented your triangle differently, if you labeled it differently, if you drew the whole thing differently, that's fine. But we have an isosceles triangle, side lengths given. Couple things we need to know. One thing that we need to know is going to be how to find the area of a triangle. Anybody remember? Very good. 1/2 base times height. In this case, we know part of it. We know which one, base or height. We know the base has a length of, by the way I drew it, 10. We are going to drop in an altitude, throwback to previous vocab. An altitude makes what kind of angle with the base? A right angle. That's helpful for us. Does anybody else remember, bless you, what's special about the altitude of an isosceles triangle? It does what? Makes what equal? Right, so down here, that's now, don't go based on how I drew it, go based on what you know about geometry. These each now have a length of 5. Do we remember that from last semester? So again, it doesn't really matter how you drew it. It matters about how it gets labeled. Now that we've done all that, we can find the height of the triangle using the Pythagorean theorem. Are we looking for a leg or the hypotenuse? We're looking for a leg, so A or B. I'll, again, just use A. So A squared plus, what should I plug in for B? 5 squared equals 13 squared. Questions about why I plugged in what I did, where I did? Okay. 5 squared. 13 squared. To solve, we should Subtract a squared equals 144. Then we would need to simplify the radical. We should take the square root so that there is a radical to simplify. A would equal 12. So A represented the height of my triangle. So now I can go back to my area formula. We already talked about the base of the triangle means the whole bottom side, which had a length of 10. And the height of this triangle ended up being 12. Okay, now I don't really care how you do this. If you want to take half of 10, then times 12, or multiply 10 times 12, then take half of that. No matter how you do it, you would get the area equals 60. Our units, meters squared, because it's an area. Questions, concerns, need more time? Ready for our last page of notes for today? Okay, here we go. A Pythagorean triple. Pythagorean triple is a set of three positive integers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. So what this means is that you don't end up with any radicals that you would have to simplify. You wouldn't end up with any decimals, things like that. They're all just integers. So some of the common ones are listed, and then below we have space to write some of their multiples. So for example, if I were to take the numbers 3, 4, and 5 and multiply them all by 2, what would I get? 6, 8, and 10. I could do the same thing for 5, 12, 13. I'd get 10. Okay. 8, 15, 17. 30. 4. Okay, for 7, 24, 25. And 50. Let's also go ahead and multiply them all by 3 just for funsies. Oh, that's not so bad. The first one would be 9, 12, 15. The next one would be 39. Next one. 51. Yeah, that one. Okay. The next one really shouldn't be bad. 7 times 3 is. In 3 days there are how many hours? And 25 times 3. Okay. Should we do 4 too? No. Oh, fine. Okay, so all of these are Pythagorean triples. It's kind of nice to be able to identify them. I'm not going to necessarily require you to have them memorized just yet. I would, though, memorize at least the basic ones. Of course, the more we do these and the more they pop up, probably the more you'll recognize them. Anybody need more time on this slide before our last example? Okay. All right, last one. Find the length of the hypotenuse, use both methods. So both methods meaning Pythagorean theorem way and Pythagorean triple way. Which way do you think is faster? You think the theorem's faster than the triples? Triples is faster. If you look at this triangle, you should see 2 numbers that we wrote down, and all you need to do is identify the third number from that set. What is it? 26 is going to be the length of that hypotenuse. If you have your Pythagorean triples memorized, you would know that right away. Now, I'm going to assume most people don't have that one memorized. Okay, so you could default back to the Pythagorean theorem. And in this case, are we looking for A, B, or C? C. The one across from the right angle is always C. So, A and B, you get to pick which one you plug in where. And then X has to go in for the C spot. 10 squared. 24 squared. Add them together. To get X alone, we should square root. Calculator comes in handy, but of course we should already know that the square root of 676 would end up being 26. Now, if you had your triples memorized, you'd be able to go straight to the answer. Save you a little time. If it's a triple on the test, you could go straight to the answer. If you don't recognize your triples, though, then you're going to have to do the work to find it. If you know it's a triple, you could just write the number, but you better be sure it's a triple.
Okay.
Does that make sense? Okay. Also, just as a... Never mind. We won't go there right now. Okay. Your homework should be on your assignment guide, but here it is.